Greetings, Ridge Runner here. This is my second in a series of videos on the topic of directly downwind faster than the wind. The topic of this video is the details of this specific cart. This is my first cart, cart number 1. And so let's get right to it. Okay, let me talk a little bit about the features on this cart. Well, for starters, I have a very easily replaceable propeller system that enables me to swap propellers easily to go from in this case, a 2-prop to a 4-prop. There's a friction fit in here, interface fit. This is a 5mm tube here, and this one has an inner diameter of 5mm and a snug fit. I can also swap it very easily to turn it from a pusher to a puller. It has a steering mechanism, radio-controlled steering mechanism. It has a 70-75, very rigid, doesn't bend frame with a attachment here that's can be easily disassembled, and that's basically the features in a nutshell. Let's go into some of the details. Okay, first let's take a look at the dimensions. The distance from the rear wheel to the front wheel is a little over 24 inches. The height to the bearing is about 9 inches, a little over 9 inches, and to the prop is about 10 inches. The distance between the wheels is a little over 7 inches. The location of the center of gravity without a prop is located right about here that I've marked with a dot on the top. Here are my kitchen scales I'm going to use to weigh it in grams. Here's the cart without the prop on it. And as you can see, it's about 200 grams. And the 4-bladed prop is about 40 grams, a little less. A single-bladed prop, just under 20 grams. To measure the weight distribution, I've placed an extra cutting board on top of the table here that's about the same height as the scales, so that we can place the cart on here such that we can measure the front and the back. Let's find out what the front weighs here. Let's turn it on and calibrate it to 0. Place the front wheel on it. Okay, it's stable, and it is about 100 grams. Now, this is without the prop on it. If we swap it around, the rear is also about 100 grams, a little over. Calibrate the scales. We've got the prop on it now. And with the prop on it, it's about 120 grams at the front. And then if we turn it around, you see that the rear is still right about 100 grams. Okay, next we'll try it with a double prop. Okay, now I've got the quad prop on here, and let's go ahead and tear this out. Okay, we've got a good tear there. Now let's place the quad prop jobby on there and see what she reads. It's about 140 grams. And if we take it and rotate it around so that we measure the tail, we've got, once again, about 100 grams. Okay, here's a detailed view of the radio-controlled steering mechanism. On top is a single-cell LiPo battery, 160 milliamp hour, that is held on with a single cable tie here. It's connected to a circuit board in here that has the receiver and servo that's held on to this spruce plywood plate here with a single bolt, and then also held in place with this yellow shrink wrap tubing that holds it very steady. The servo is connected to the steering arm, and the steering arm is attached to the steering shaft with a single set screw. There is a bearing on the top and a bearing on the bottom. The wheel is attached to this, which contains two bearings in there. This is actually from the tail rotor on an HK450 helicopter, which is also where this case came from. And that's that. Here's a detailed shot of the upper bearing block. We've got a 5mm bearing that holds the 5mm shaft. We've got a 70-75 piece of tubing here. It's actually from a K2 145 hang glider undersurface batten, which I bent with much difficulty, as 70-75 does not like to bend, but once it's bent it holds its shape very well. That was one of the design criteria I wanted to have for this, so that it would have constant performance. You don't have to bend this frame and affect this upper bearing all the time like the original cart. So this one is going to have very consistent performance, hopefully. Okay, here's a detail of the rear frame attachment. I made an aluminum structure here that is bolted in with two bolts to the case here. And the shaft here is pop riveted to that. It's also potted with some PC7 epoxy paste here. So this is a very rigid connection between the shaft here and the case here, and that enables us to very fine-tune and get the upper bearing to where it's very well aligned and does not change. Okay, here's a detailed shot of how I've got the wheel attached. We've got a 5mm carbon shaft as per the build video. This one actually is a thicker walled tubing, however. I've put a 256 screw about a 1/2 inch into the axle here and about a 1/2 inch out, and I've attached the wheel with a pair of blind nuts, and it makes the wheel very easy to remove. Okay, I just want to verify that the propellers that we have are in fact a GWS EP1575 for the single prop, and for the double prop is also an EP1575 on both of these. Now for attaching the propeller, I drilled out the propeller so that it would have a snug fit with a 6mm carbon tube, which fits in quite nicely, and I have it glued onto this shaft. And this shaft is actually split a little bit so that it can fit over the 5mm prop shaft, and then all that's held together with a piece of shrink wrap on each side. This enables us to attach it in either direction.